Hello everyone, dear students. I am Dr. M.Ghumare from Sanjivani College of Engineering, Kopargaon. Today I am here with another new content on concrete mix design. As a site engineer, we often come across to the concrete mix design. So in this video, we will get clear idea why concrete mix designs are important on the site, because at every place or place to place material properties are varying. So cement, type of sand, type of aggregate and their properties are changing from place to place. That's why all the standard proportions we are using for M15, M20, M25, that is 1 s to 2 s to 4 or 1 s to 1.5 s to 3 or 1 s to 1 s to 2 will not often give the recommended results or required results. That's why concrete mix design is nothing but a process of determining the proper proportion of cement, sand, aggregate and water with suitable admixtures required as per the field requirements. As I discussed before, material property changes from place to place. Hence, at every place, standard proportions are not suitable. Hence, as per the locally available material, whatever sand is available, aggregate is available, or cement is available, we must test all the properties of the material in the laboratory and use the same material for the concrete mix design, so that that particular project or concrete will be economical. Means, in other words, the concrete mix design is promoting the use of locally available materials. So that is one of the important advantage of concrete mix design. Why concrete mix designs are important? So it will ensure the required strength and quality. It will ensure good workability for longer periods. It will control or reduce the thermal cracks. It will promote the fast constructions. It will reduce the segregation and bleeding. It will reduce the shrinkage and creep. It will also ensure the ease in finishing concrete to use, or it promotes the use of locally available material. And the last point that is very important, that is to ensure durable and waterproof structures. That is the requirement of every structure. Now we'll discuss about the factors affecting mix design. So here in the chart also you can see what are the various factors which are affecting the mix design. That is water content, cement content, aggregate grading, aggregate nature, temperature at the particular location, humidity present, compaction types used, concrete placement, concrete transportation method, and so many. So here these are the all the factors that is very important uh, before going for any mix design. So in that, you know that coarse aggregate plays an important role to get the strength to the concrete, because coarse aggregate normally consumes around 70 to 80% volume of total concrete. Hence, to get a durable and good concrete, your aggregate quality must be very good. Otherwise, if you are using more cement or other particles, that will be also not any use. Hence, uh, by knowing the local conditions, by knowing the structure requirements, accordingly you should design the concrete. For the concrete mix designs, we are using different methods. There are 10 to 15 methods available in the literature, but specifically in India, two methods are most popular. That is IS code method, that is as per IS 10262 2019, and second one is the DOE method, because it is also similar to the IS code method, but here some standard references and charts are used. Now you will go for the actual problem. So here I have intentionally taken a problem of low grade, that is M35 grade of concrete. It is oftenly asked or oftenly need in the field also. So here M35 grade of concrete is proposed. Workability required is 100 mm slump. Exposure condition I have taken severe type of cement OPC 43 grade. Here if the OPC 43 instead OPC 43, if it is OPC 53, then only the curve will change from 2 to 3. Okay. Concrete non-pumpable, normally pumpable concrete required when you are using the RMC concrete. RMC concrete. So in RMC we need more flowability and workability. Hence non-pumpable concrete I have promoted. Yes, specific gravity of OPC 43 grade cement is mentioned. So it is 2.95. Normally for OPC 53 it is 3.15. So specific gravity of fine aggregate 2.71, specific gravity of coarse aggregate 2.74. I have taken non-SSD aggregate. The SSD means what? Saturated surface dry aggregate. Means there is no moisture on the surface of the aggregate. Then size of aggregate, I have normally taken 20 size, which is commonly popular. That is 3/4 inch, or upon normally we are calling it as a pound inch aggregate. That is the 20 aggregate. And zone of aggregate, I have taken zone 2 as per the IS code. Now starting with the step 1, as per the IS code 10262, procedure is like this: to find the target mean strength, that is FCK dash. So FCK dash is equal to FCK plus 1.65 into S, where S is the standard deviation, and for M35 grade of concrete it is 5. So 35 plus 1.65 into 5. So this particular addition is 43.25 MPa, or in other way also, as per the IS, we can calculate FCK dash as a FCK plus X, where X is 6.5 for M35 grade. So it is given in table 1, on page 3 in IS 10262. You go while going through this particular problem, you just keep your IS code with you, so that whatever I am discussing you will better understand. So next step, so here what we got from this particular first step, that is FCK dash, or target strength that is required, is 43.25 MPa. Now step 2 is to fix the water cement ratio. To fix the water cement ratio, there are 3 to 4 criteria. In that, first one is to use the figure 1 that is given on page number 4 of IS code. So here I have recommended for OPC 43 grade, that's why I am going to use curve 2. So for curve 2 and FCK dash 43.25, if you interpolate it, you will get the value of water cement ratio at 0.39. Again, second water cement ratio value is decided on the basis of exposure condition. So here I have mentioned it as a severe. So as per IS 456, page number 20, table 5, for severe condition, you will get water cement ratio as a 0.45. But when you are going to adopt this value, you should always go for the minimum value of water cement ratio, and minimum of 0.39 and 0.45, the value is 0.39. So I am going to refer water cement ratio as a 0.39 for this mix. Now third point, or third step, we can say, to find out the approximate air content for non-SSD aggregate and 20 size aggregate. You know that from table 3, for 20 aggregate, uh, to approximate air content is taken as 1%. 1% means what? 1 by 100. So that is equal to 0.01 cubic meter of total volume of concrete. Means if you are considering 1 meter cube of concrete, in that 1% will be the air content. 1% it is 1 by 100, that is 0.01 cubic meter. Now after knowing air content, next step is to find the water content. So to find the water content, you should use table 4, page 5, IS 10262. For 20 aggregate, it is given as 186 kg per 186 kg. Okay, it is not per liter, 186 kg or liter. Okay, so this is dash, consider this slash as a or, kg or liter. Okay, and uh, this water content will vary according to the slum required. If you are using the uh, because the table 4 is given for 50 slum value, but now here given that 100 slum. So for 100 mm slum means what? 100 minus 50, so we'll get 50 mm difference between slum value. And as per the IS code provision, clause 5.3, page 3 and 4, for every 25 mm increment in slum, you should add 3% of extra water. So here we need 50 mm extra slum, that needs 3 plus 3, that is 6% extra water for 100 mm workability. So total water required will be 186 plus 6 by 100 into 186. So total water, here I found it as a 197.16 kg. So after knowing water content, next step is to find out the cement content. So from water to cement ratio, we know that it is 0.39, and now we have just calculated the value of water, and that water is 197.6. So instead W, put the value of water 197.6, and ratio is 0.39. So unknown value is cement. So find out C is equal to cement. It is 5.53 kg, but as per severe condition, using that table 5, this value is recommended as 320 kg per meter cube. So and again, as per 456, the maximum cement content should not be more than 450 kg. So we should recommend the maximum of these two. So for severe condition, we required it as a 320 kg, and for as per IS 456, 450 is minimum maximum value. So you should go for maximum 450, and do not take this 505, because we should follow the IS code rule. So we'll recommend the cement value as a 450 kg. So what we did till now, we have calculated water cement ratio, we have calculated water content, we have calculated cement content. Now we'll move to find out the aggregate content. So here you can see, here the steps are given to find out the total aggregate content. So use table 5, page number 6 of IS 10262 for 20 mm size aggregate and zone 2. You will find that, and for water cement ratio 0.5, the aggregate content is 0.62, but water cement ratio is here is 0.39, and this value 0.62 is given for water to cement ratio 0.5. You just read the heading of table, you will find that the values given in the table are for water cement ratio 0.5, and here our value is 0.39. So we should add some aggregate content. As the water cement ratio decreases, the coarse aggregate content increases. So what is the difference between these two values, 0.5 and minus 0.39? So there is a difference of 0.11. So as per the clause 5.5, page 5, IS 10262, so there should be a increment of addition of 0.01 for every increment or decrement of 0.05. So here water cement ratio is decreased by 0.11. So we should add few aggregate. Okay. So because total course aggregate required less water for the mix, that's why we should increase the course aggregate content for given water cement ratio. So increment in total aggregate will be 0.11 is the difference into 0.01 is the increment for 0.05 difference in water content. So that's why if we calculate this, this value will be 0.002 of additional aggregate added, and that value of 0.0022 should be added in 0.62. So same thing I have did here. So 0.62 plus 0.002, so total CA content will be 0.642 of total volume. So among this 0.642, so if you consider total 100% of volume of coarse and fine aggregate, if you deduct this value from 1 minus 0.642, you will get the total volume of fine aggregate. Okay, so in this way you got the total volume of coarse aggregate, fine aggregate. Now you have to calculate the actual volume of other material in cubic meter, because we have calculated water, cement and air in meter cube. So now you have to calculate, in kg. Now you have to convert it into meter cube. So it is very simple formula to convert it in mass of the particular material divided by specific gravity multiplied by 1000. It is given in IS code clause 5.7, page number 6. Now here, if we see the volume of water, it is 197.16 kg is the volume, divided by 1 specific gravity multiplied by 1000. You will get 0.197 meter cube of volume of water. Now to find the volume of cement, we know that we are going to use 450 kg of cement divided by specific gravity 2.95 multiplied by 1 by 1000. So total volume of cement is 0.15 meter cube. To find the aggregate volume, so from 1 meter cube, here 1 indicates the 1 meter cube minus cement volume minus water volume and minus air content 0.001. Means from 1, if you deduct the cement aggregate cement water and air volume, so you will remain the quantity of aggregate volume. So here total aggregate volume is required is 0.643 meter cube. Now you have to calculate the mass of the coarse aggregate. So in the previous step we have calculated the total proportion. Here you can see 0.642, 0.352 for fine aggregate. So total volume of coarse aggregate multiplied by volume proportion of coarse aggregate 0.642 multiplied by specific gravity multiplied by 1000. So here you will get the mass of coarse aggregate, that 1131.08 kg. And similarly find out the mass of fine aggregate, the total volume of coarse aggregate multiplied by here this volume proportion 0.358 multiplied by specific gravity multiplied by 1000, you will get the mass of fine aggregate. And then now here we know all the quantities. Now write down all the quantities here. Cement 450 kg, fine aggregate 623.82 kg, coarse aggregate 1113.08 kg, and water content is 197.16 kg. Okay, so here we are considering cement volume as a 1. If you divide this 623.82 by 450, you will get 1.38. Again 1131.08 divided by 450, you will get 2.51. So we got proportion for M35 grade as a 1 as to 1.38 as to 2.51. So this is the standard proportion for M35 grade of concrete, and this standard proportion is called as concrete mix design. So there may be slight changes in the water content due to presence of moisture content in the coarse aggregate or fine aggregate. If there is a water absorption of the material, then you should add that particular correction as a additional water. And if there is a moisture content in aggregate and water, so in laboratory you should find out what is exactly the water content in fine aggregate, coarse aggregate, and that amount of water should be added during the mix, so that hydration process will completed in very good manner, and you will get the 100% strength. So this is the standard proportion 1 as to 1.38 as to 2.51. So it indicates cement content, sand content, aggregate content, and water content. So for 50 kg, suppose for one bag you have to calculate, you just multiply 1 means what, 50 kg multiplied by 50 into 1.38 and 50 into 2.51, you will get the total material required for one bag of cement. Likewise you can calculate for two bags means what, 2 into 50, that is 100 kg of cement, 100 into 1.38, 100 into 2.51, you will get that proportion of particular materials required for the M35 grade. So in this way I have tried to explain you in a simple way how to do the concrete mix design. Just follow this particular procedure. Thank you very much. क्यों ना विंडो शिफ्ट